from the 00 Stewart Calculus, chapter 2.8, question 49, asks us to identify the f, f prime, and f double prime function, and why we would identify these as our choices. So a few things that we can look for are positive and negative slopes, and we can look for zeros and zeros on the horizontal tangents and zeros, and we can look at maybe polynomial powers. So if I take a look at this, one thing I want to do is relate the max points here with the zeros. So I've got a max point there that relates to 0 on the blue. So B and C appear to be derivatives of each other. So C looks like the derivative of B. And if I just test this, check this here, it looks like I have positive slope on the B. And it's all positive up to here. It looks like it is flattening out, so it's going towards 0. It's my 0 slope. I have negative slope all the way through here. And again, it looks like it's flattening out here, so the slope seems to be getting close to 0 here. So it looks like definitely C is the derivative of B. Now, looking at the other zeros here, we have a max point here that relates to 0 here. And notice that this point here, although it doesn't really match the max of the C. So, and we also know that C is a derivative of B. So looking at this here, the horizontal tangent appears to be the 0 of B. So what we can say then is this: A prime relates to the B graph. We know that B prime relates to the C graph. So it looks like that F is our A function. F prime would be the B function. F double prime should be the C function. Okay, and again, we can check a few things here. We have positive slope on A, that's all positive y values on B. Negative slope on A, negative slope on B, it tends to 0, that tends to 0, that works. And we did the same analysis between B and C, as B is a function and C as its derivative. For number 50, we can do the same thing. Now, in this case, we can maybe use some polynomial functions as well. But again, we want to look for horizontal tangents that relate to zeros. Okay, those relate to each other. So it looks like the D function or the C function is a derivative of D. We can also see that we have a horizontal tangent here, and both A and B have a 0 at that point. So we're going to first of all just keep track of this. D prime seems to relate to C. Now C prime, it could either be A or B. So if I look at the slope of C, it's negative to positive. Here I have B is negative y values to positive y values, where A is not. So it looks like B is going to be the derivative of the C function. And then if I take a look at A, the horizontal tangent, it looks like there's a horizontal tangent on B, and it looks like there's a 0 value at A. This is all positive slope. This is all positive y coordinates. So it looks like B prime relates to A. Okay? And we can take a look at this and also say that, well, we have a polynomial function here. It relates to this function here. So let's say that this is an odd polynomial. The derivative should be even. The derivative of an even should be odd, which is a blue. Derivative of the odd should be an even function, which is this parabola looking function. So we can say then that f is going to relate to the D function. F prime then should be the derivative C. F double prime should be the derivative of C, which is B. And the third derivative is the derivative of B, which is A. So it goes D, C, B, A.